Hey, so here's the thing. On the AP test itself, there's going to be a lot of questions, a lot of them, where the way to solve it is to find the area under the line on a graph. So let's just briefly talk about this. All right, here's an example of one of the kind of questions they'll ask. So I just want to make sure that you understand how to do this. Most of you do, but in case you don't, watch the screencast and maybe it'll help. Okay, so the thing is, to use area under the line, you want to just say to yourself, what happens if I take the y variables units, in this case it's velocity in meters per second, and multiply it by the x values units, which in this case is seconds. So if I said meters per second times seconds, I'd end up getting meters. So you've got to know, okay, meters measures displacement. So in this case, on a velocity versus time graph, the area under this line, that represents the displacement of the object, how far it is moved from its original position. So I just find the area, so I would just say in this case, well, I've got 6 meters per second times 10 seconds. That gives me an area this large, a rectangle this big, and that gives me 60 meters per second. Okay, not so bad. But the trick is you need to look and say, these units times these units, what do they give you? And then you have to understand the physics enough to know, okay, that's displacement. All right, let's try another one. All right, so let's do it with an acceleration versus time. So now I've got meters per second, or meters per second squared, however we want to express that, times seconds. So meters per second squared times seconds, one of the seconds cancels out, leaving with meters per second. So that's going to be a velocity value. But I've got to keep in mind that acceleration is defined to be the change in velocity over time. So when I solve for velocity, I'm really solving for the change in velocity, and that's going to be important, okay? So I do the same thing. I'm going to say 6 meters per second squared times 10 seconds. That gives me 60 meters per second, but that's how much the velocity changed. So let's just say the prompt said, well, I had an object whose initial velocity was traveling in the negative direction at 20 meters per second. It underwent this acceleration. What is its final velocity? We just got to remember that final velocity, I'm sorry, that change in velocity always means final minus initial. So in this case, I would say the change is 60 equals my final minus my initial, which was negative 20. And so in this case, I'm going to solve for VF, so I have to add negative 20 to both sides, which gives me 40 meters per second as the final velocity. So you got to be a little bit careful with that. Now let's look at one last thing. I'll be done here. More often than not, the area bound by the graph line does not depict a rectangle. Usually it's a slope. Okay, and it can be more complex than that, and you can figure that out. But for right now, let's just talk about this. So if I have a sloped line like this, then what I've got to do is I've got to figure out what the area here is. So the way you do that is you just draw a rectangle that would contain all of this. So I just take the maximum value of the y, and I use that as the y value, and I use this as the x value, so I get this rectangle here, and I'm just going to chop it in half. So in this case here, I've got velocity in meters per second, I've got time in seconds, so I'm going to end up solving for a displacement. Let's see what that displacement would be. I say, well, the area of the rectangle shown in purple here would be 8 times 10, that's 80 meters. But the area bound by the graph is only half of that. So I'm going to divide that by 2, I'm going to get 40 meters. So the displacement of the object is 40 meters. Okay? And one last thing. I've just noticed students sometimes make this boo-boo, so let's not make this boo-boo. The area under the line doesn't mean just take this and find the whole area on the graph, because keep in mind, this goes to infinity. It's when I say the area under the line, I'm saying between the line and the 0 value for the y variable. All right, so it's always this to the 0 line. So this would be wrong. I wouldn't take this entire area here. The only area I would take would be this area here and this area here. So between the line and 0, between the line and 0. So if I was to calculate it then, what would be the displacement, the net displacement of over the total 10 second time interval? So I'd first say, well, I've got here, this is 8 times 7 divided by 2, all right, and that gives me 28 meters. This one would be negative 4 is what this value is, and this is 1, 2, 3, so negative 4 times 3, and again divided by 2 gives me negative 6, and I combine those two, so 28 plus negative 6 gives me 22 meters of net displacement. Okay, thanks for watching. This is a skill set. If you're not comfortable with now, you're going to get that way because we're going to do it a lot this year, and don't ever hesitate to come in and get help from me. Thanks for watching.